This is first page of the 10.2.10.5 review worksheet number 2. A particle moves in the xy plane so that its position at any given time is by with x equals cosine of t and y is equal to t cubed. What is the speed of the particle? So to find the speed of the particle, we're going to use this formula. It's the magnitude of the velocity vector, which is the square root of x prime t squared plus y prime t squared. So first we're going to find the velocity vector, which is going through the rule that we have for cosine of 5t. The derivative going through chain rule will be negative sine of 5t times 5t's derivative, which is 5. So cosine of u becomes negative sine of u times u prime, and u prime is going to be 5. The derivative for t cubed, we go through power rule, which is just 3t squared. So here's our velocity vector. We just have to now do the magnitude of the velocity vector to find the speed. So square root of x prime squared plus y prime squared. So that gives us this value. Then plug in 2 into the remaining t values, and then we get 12.304 as the speed. Okay, number 2, position of the particle is given by x of t and y of t. Find the magnitude of the velocity vector. So same idea. We find the derivatives, we find the velocity vector, and then we can find the absolute value to find the speed. Here we can think of this as 1/3 t minus 2 cubed. We can go through power rule, bring down the 3, keep the parentheses, subtract 1 from the exponent, multiply it by the inside function's derivative, and then the 4 goes to 0. So this cancels out. We're left with just t minus 2 squared. And then y prime becomes 2t minus 4. We plug this into our formula and replace all the t's with 1. So we're going to get 1 squared plus negative 2 squared, which is root 5. Finding the total distance, we're going to accumulate speed over the course of the two t values. So from 0 to 1, the square root of t minus 2 to the 4th plus 2t minus 4 squared. Okay, so we're just plugging x prime, y prime, basically accumulation of the magnitude of velocity over the course of time. And in our calculator, we're going to get 3.815. Okay, second page. I'm sorry, part C. Part C says, when is the particle at rest? Particle is at rest when x prime and y prime are both equal to 0. When y prime is 0 and x prime is 0. So we can figure out, we know what x prime is, which is from above here, t minus 2 squared. We set that equals 0, we get t equals 2. Y prime, we set that equals 0, we also get 2. So particle is at rest when t equals 2. So when t is equal to 2, the position at that time, we can just plug 2 into the position function. And if we plug in 2, we're going to get 0 plus 4, and then 0 minus 0 plus 4. So position, I'm sorry, not 0, it will be 0 minus 4 plus 4. Let's see, 2 squared, 4 minus 8, my bad, 4 minus 8, negative 4 plus 4, which is 0. So the position at that moment in time will be at 4, 0. Okay, back page. Number 3. For what values of t does the curve given by the parametric equation have vertical tangent? We know vertical tangent will occur when dy over dt is equal to 0. So, I'm sorry, dx over dt is equal to 0. Vertical tangent. So vertical tangent is where the denominator of the slope formula is equal to 0. So we know slope formula is dy dt over dx dt. So we know this is slope, and slope is undefined if the denominator of the slope formula is 0, so we can set dx dt equal to 0. But this also must mean that whatever will make this 0 can't also make this 0 as well. So we have to make sure and double check that the critical point that we have here is not going to conflict and make dy dt equal to 0. So to find dx dt, we can find the derivative going through power rule here. We'll get 3t squared minus 2t. We set that equal to 0. Solve for t, we get 0 and 2/3. Okay. And if we plug 0 into y prime, y prime will be 4t cubed plus 4t minus 8, and that will produce a value that is other than 0, so that's okay. 2/3, if we plug 2/3 into dy dt, we're also going to get a value that's non-zero, so that will ensure that both these dx dt's values of or both t values of 0 and 2/3 will cause dx dt to be 0 but not dy dt, so therefore we ensure that we will have vertical tangents at 0 and 2/3 only. Number 4, path of the particle moving in the plane is defined parametrically by x equals sine of 2t and cosine of y is equal to cosine of 5t. What's the speed of the particle at t equals 2? We just go through our formula, so root x prime squared plus y prime squared. So we just plug into our formula here. Sine of 2t becomes cosine of 2t times 2. Cosine of 5t becomes negative sine of 5t times 5. And we just therefore plug in t into the remaining t 2 into the remaining t values, and in our calculator we'll get 3.017. Okay, number 5, distance traveled from 0 to 4 is given by the vector t squared t. So the distance traveled is just going to be the definite integral from a to b for the square root of the magnitude of the velocity. So we need to find the velocity vector first. So t squared becomes 2t, t becomes 1, and we plug this into our formula. So square root of 2t quantity squared plus 1 quantity squared from 0 to 4, and that matches the form for part D.